Welcome to our continuous testing meetup online. So we start our meetup for today. So at first, I want to say a big thank you to our sponsor, Source Lab Training and to Amusement for allowing us and helping us to organize this meetup, for paying their fees, to giving us time for prepare these meetups. So let's move forward. In case you missed our last meetup, so please go to our website, continuoustestingmeetup.com. You will find there the information about the last events, and also you can find there the video recording of the meetups. So what we have today, we have Matthieu here with his topic, faster, stronger, better. Can we make performance testing continuous? Thank you, Matthieu, to being here, and you can start share your slides. I will stop sharing. And for all participants, please mute yourself. And if you have any questions, and I hope that you will have questions, please ask it at the end of the topic. So, Matthieu, please start.
I'm unmuted. That's better. Okay. Do you see my screen?
Yeah.
Yes. Cool. Very cool. So, hello, everyone. So I'm Matthieu, like Axana said. Thank you for having me today. So just so you know a little about me before we get started. So I'm a performance testing engineer and have been for the past 15 years. I'm a freelancer, helping companies come up with their performance testing strategy. I train and coach, and I'm also very hands-on, so working mostly on software against financial crime since 2019. I live in the beautiful city of Nantes, which sadly is far and away from all interesting mountains. And since 2023, I co-organized the We Love Speed conference about web performance. So without further ado, let's get started. So faster, better, stronger. Can we make performance tests continuous? Of course not. Thank you. So with that terrible joke behind us, let's dive in. So what is performance? So let me just move the chat window, chat box, chat dialog for a second. Yeah, okay. So what is a performance test? You'll see there's a few traps in there, so please stay alert. So you take a system, right? Let's just say the guy is a system. You put workload through it, you monitor how it reacts. Lukasz says, I cannot hear you. Can you guys hear me?
Yes.
Okay, cool. So you monitor how it reacts, and that's quite simple. That's basically it. Yet the monitoring part is very often overlooked. And that's the first word of advice I have for you today. It's that you need to look beyond response times. If you want to know if you're making the same mistake as everybody else, the question is, what's left of your monitoring scope once I take response times out? Expectedly, you should have a list of things. If you do not have anything, you have to ask yourself a whole lot of questions. So now, what is the point of doing all this? So as you know, testing is about discovering the truth about software. We don't do it to ensure the absence of defects. We do it because simply because the absence of something cannot be proven. So we also diagnose and hopefully fix issues before they impact our user. And based on our findings, we can make informed decisions about the future. Also, unless you're in a monopolistic position like Ticketmaster, for example, you care about reputational risks and you want to avoid them. And finally, performance testing reveals the level of efficiency of your system so you can improve it and save resources. So why continuously? So that's quite simple, and expectedly that's a topic you guys are, acculturated with. So that's pretty simple. We catch defect before they reach production. That's quite good. but what's even better is catching defects before they've had the opportunity to siphon the resources of the company, mostly time and money. Yeah. So the second cut here is because I would like to take a moment to clarify one big misunderstanding in industry. And I need to do it before we go any further because it's going to affect the way you read or understand the things I'm going to show you or tell you. So I wouldn't want you to walk away from this with the wrong idea. So performance testing, right, is, let's say, putting big workload through a system and see when it breaks, right? We could say it looks like moving cargo around. Yeah, so big trucks, sorry, big planes, big ships. Yeah, so that's true. But if you do this, if you only do this, you'll be missing a big part, the biggest part of the picture, in fact. So let me try and show you. So what is that beauty? So can anyone tell me in the chat what this is? You guys have an idea? Nope, a good guess anyway. All right, so that is a tardigrade. So that's about half a centimeter long. It's found atop the Himalayas and in a deep sea. It can withstand extreme cold and, in fact, nearly absolute zero, right? So that's minus 273 degrees for you, but also extreme heat. It resists ionizing radiation at doses hundreds of times higher than the lethal dose for a human, and it can survive pressures 6 times greater than those found in the deepest ocean trenches, and also in the vacuum of outer space. So it doesn't move particularly fast, right? It doesn't transport big objects, but we wouldn't go as far as insulting this lady and say she's completely insignificant performance-wise, right? We wouldn't dare. So the reason I say this is that you need to think about performance in other terms as just big workload, right? And big infrastructures, sorry. So performance, let's start with a short exercise, right? And make sure we understand each other. So how do you tell if something is performance? So 7 pillars of performance. We can express performance through these 7 pillars. And usually at that stage, I give people candy when they submit answers, but I'm sorry, I won't be able to give you any candy this time. So just pretend you're excited, okay? So let's say you're in a car, you're going on vacation, and you reach that place. This is a place where performance is crucial, not only for you, but for the business. So please reflect for a moment. It's just going to take a second and think about the ways this system can express performance. Right, so I'll give you a head start with 2 answers. There's 5 more, at least 5 more. So the first one would be speed. That's the most obvious one, of course. So how fast can I go through this toll, right? And the second one could be capacity. So how many cars can the toll process within a given time period? Yeah. So now, please go and type out the answers you think about to win Ghost Candy. Yeah. So there's 5 possibilities. I'll give you 15 seconds to think about it, and we'll move on afterwards. Okay, so not many guesses. Not a problem. Not a problem. Okay, so the 5 other properties I had in mind, right? So efficiency. How much employees, electricity, or maintenance does the business need to operate per vehicle? You could express performance as scalability. This is usually the one that you guys find, meaning how well are they able to scale with demand? And can they open new lines? Can they do it fast enough? Sorry. And what's the maximum if there's one? Yeah. Or even stability. So how does the speed at which I go through this tool changes when the number of vehicles around me changes, or resilience. Yeah. So how does the tool recover if a lane goes down? And the final one would be availability. So you could say, can vehicles go through a working lane in a timely manner? So that's more of an overall thing. So as you can hear and see it, there's a point in measuring how well it performs, even when it's not full. And I'm reaching the thing I wanted to say is that if there's a single takeaway for today, it is that performance testing is much wider than load testing only. And it directly translates to the first advice I'll give you in a minute. So every time you hear someone talk about performance and only equate it to load testing, you can begin to question whether or not the scope is as big as it should be. All right, so next. So these are the topics we'll try to highlight issues and solutions for, right? So I want you to have a toolbox of solutions after we stop talking today. So methodology. So I'll let you take a look and ponder for a second. If done wrong, continuous performance testing has the ability to financially ruin your company. Really. So we need to navigate this efficiently. Okay. So I'm sure you're all familiar with the test pyramid, of course. When applied to performance tests, and perhaps all tests even, some metrics increase as we go up the pyramid, right? So effort, risk, cost, time, complexity, and so on. So at the very lowest level, you could find static tests, small scopes, and low volumes. And at the highest level, dynamic tests, complex and high volume. Yeah. At the bottom, tests you could run close to devs, ideally on developer environments, even their laptops. And at the top, the tests that need to leverage our bigger environments. So for example, production. And we can do both. In fact, we should do both. The one is shift left and the other is shift right. So if you're unfamiliar with the shifting right, let's just say quality doesn't end with deployment. And of course, feedback time for developers increase as we go higher and higher. So in fact, the crux of it is that you will find out you are constantly weighing your options between cost and relevance or accuracy of your tests. And it's a very fine line to walk. So when it comes to environment complexity, the first tip is production-like is extremely expensive. Yeah, so most of the time, we're not trying to predict the figures accurately. We're not trying to say, this is going to take 2.5 seconds in production. What we're trying to do is predict changes in behavior in the system. And just so you know, about 80% of the performance defects affect a single user. So you need to scale for one, and then after that, scale for many. And we don't really need a production clone to do this, right? You can downsize. So I'm not arguing against the advantages of production. Yeah, this is extremely useful, but we need to be pragmatic as to what we really need to do at the earliest stages in a continuous testing factory. So tip number one, you don't need to be production-like to get started in continuous performance testing. Second, the production-like system, so if it's not the environment, that it can be the system you test, right? The application. So more often than not, it's very complex. So you need to split the system in smaller pieces, isolate them and test them separately. So that's basically going down the test pyramid as much as you can. Again, your tests do not have to be production-like to give the first insights. Okay. Third one, at some point, you'll verge off-road and be tempted to merge every single test in one big test. Do not do this. This is a mistake, right? So all test quality metrics go down as the test complexity increases. It's the only way to highlight some issues. Sure, we need big tests, of course, But that level of complexity is a hard no in the CI/CD, or at least until you've reached a maturity level that is satisfactory, right? So that's the reason for this little footnote here. About data sets, so that's a very frequent question, right? To have meaningful data sets, you really need to know your system and to know your customers well, because these days, I wouldn't say most, but a lot of the applications we test are SaaS based, right? So you can see the data that your customers are handling. But we still have, I'd say, old school solutions that the clients host themselves, right? And you do not necessarily know the data they're handling. So it's difficult to get right with synthetic data, a data you generate for your test. It's difficult because of the volume that you require, and it's difficult because of the directions in which the data the system handles can grow or become more diverse. Okay, so if you can, you take production data, you anonymize it, you test it, and please experiment with it. So you can see in which dimensions of growth an increased volume affects your system the most. So you still need to explore, right? The production data is best. That's the take for this. When it comes to dependencies, especially third parties, they add to the pile of uncertainties, let's say. Plus, some vendors actively forbid you from doing load tests or even performance tests at all on their services, even test environments, okay? So you need to mock, you need to virtualize these third parties, and you need to add latencies, because when you use a mock that answers in, let's say, 1 nanosecond, of course, you can expect the system you test to behave differently from what you see in production. So again, we're not trying to reproduce exactly what production goes through, but 1 nanosecond versus even a millisecond can make a world of difference. So you need to add latencies in your virtualized services. 6, so be a good farmer. Traceability really is key. You need to identify and trace your inputs. So that means software build, data sets, environment configurations, anything that is part of the system you test. And you need to keep track of what you do, because when you find something, you need to be able to say, this is the formula I applied to be able to produce these defects. Of course, that's something that you folks know about, because functional testing, if that's your line of work, requires this as well. But performance testing really needs you to go a bit further, because a tracking environment is also extremely important. And when I say environment, I also mean sizing, right? And the configuration as well. So if you're not familiar with this picture, it's a representation of what we call the butterfly effect. So of course, flakiness is a problem, yeah, but even more so on performance tests. Small differences will lead to different outcomes, and sometimes very different outcomes. So you need to take care of your setup and tear down phases. You need to take care of the installation and configuration of your testing environments. And again, it means also at maybe even a hardware level. Yeah, they're very key to mitigate flakiness. Automation maintenance. So that's a big problem for performance testing, and I'll explain it to you in a second if you're not familiar. So this one is a bit convoluted, but please bear with me. So consider a front end on the right-hand side, presented by, let's say, a simple login page. There are multiple ways your automation can interact with it. Yeah, so it can launch a browser, load the resources, render the page, and interact with the objects. That's usually what you guys do. It can also send out series of HTTP requests that reflect what the browser would do, hopefully. So doing it via protocol is the most prevalent method in the industry for several reasons. First, browser level automation is relatively new compared to protocol emulation in the field. It's also the more stable option, and it's considerably cheaper as far as resources go, about at least 200 times cheaper than a browser level automation. But it's also at risk when dealing with the front end, because since you don't render the page, it doesn't run the JavaScript layer. And as a result, if the client side is modified, to send out a new request, the browser level automation adapts automatically. Yeah, the protocol level doesn't. So you don't know when you're obsolete unless it breaks, which is far from ideal. The browser level approach is much more stable, provided you have good practices in place for UI stability and being able to identify objects on the page. Right? It's less likely to break, but it's also, like I said before, way more resource intensive. So if you're thinking about running a load test with a significant load, think twice before relying only on browser level automation. So of course, the takeaway here is you can also look for synergies. So a big upside with this kind of automation is that you can leverage your automated functional test suite to update your script. And that's a very big plus that doesn't really translate to protocol level automation. So long story short, the best solution to ensure the biggest scope is just to do both. Right. So thankfully, some tools support both protocol and browser level automation, but they do, but not many, and not all of them, of course. Tip number 12, you cannot keep up without the developers. To conclude on that side, you have to accept what is a sad reality. You just can't keep up with them. There will be changes that break the scripts. So you need to onboard the developers and rely on them to update the scripts. Again, we're talking about continuous testing here, right? So a build that goes through 5 minutes ago during your lunch break, of course, you've not been able to update the scripts. Yeah. So if you don't do this, you'll be stuck with the traditional back and forth that just isn't compatible with continuous testing. Execution time. So in performance testing, some things only appear in long tests. So as you may know, we have an entire field of testing dedicated to this that is called soak testing or endurance testing. In this particular example, you can see that the drift in memory consumption spans over about 24 hours. Yeah, so within a 30 minutes test, for example, it would be pretty difficult to catch it. But these tests are quite compatible with short feedback loops. So you have to split your system and attach your various models to different orchestration modes. So you need to keep your longest tests out of the way of your CI/CD, at least in terms of blocking capability. Your devs, of course, won't be happy with waiting for the 24 hours long test to finish. So as far as blocking tests go, your critical tests are also absolutely useful in the test chain and should block a defective build from moving forward. You can schedule also configuration tuning, like so tuning tests and dataset dependent short tests for your weekend runs. So that's a way you can explore the possibilities of your test data set. And surely your soak tests and all other demanding tests could also run over the weekend, for example. So yeah, don't do anything complicated right now, at least not blocking. Do it later on and possibly outside of the usual trigger system, but with a schedule, for example. 14, you have to know your tools, because most tests are destructive when it comes to data. And you need also to be able to repeat them at will. So it means you be loading and reinstalling platforms constantly. So you need to leverage the inner workings of your platform to streamline this process. So to give you an example, a current client of mine runs nightly front-end tests that require 4 hours each to load the required Oracle databases before the test can even start, right? So that's hundreds and hundreds of gigabytes. I recently took it down to 11 seconds, saving about 1,000 hours of pipeline availability over a year, just by leveraging the containerized database system that lives inside the Oracle system. Also, smoke tests are good. They are extremely useful. I don't know if you know this saying, slow is smooth and smooth is fast. So if you add a short time window of smoke tests before your performance tests, you will increase your the success likelihood, because defective tests will stop right away and never launch. So the proportion of tests that go until the end and really deliver value will increase. Now, analysis and interpretation, and that's really, admittedly, the biggest part of it, because performance testing is really big on an analysis. No requirements, no tests. I believe you folks also apply this. It's also very true for performance testing. So the test objectives need to be really clear-cut. If you don't know whether a given value is acceptable until you run the test, you will make bad decisions. And your CI/CD will never act as the fuse it's supposed to be. It will never prevent defects from reaching production if you don't have these SLOs, right? So service level objectives. If you're unfamiliar with the notion, you could check out the Google's SRE book, right? Site Reliability Engineering book. So you need automated checks, and you need to stick with the principle that I've talked about earlier, which is one question, one test. Also, make sure your metrics are kept raw, because aggregates hide information from you. So with the raw data here, you can clearly see there's a threshold effect involved, right? So possibly or probably caching here. So if had I only kept the raw data, the aggregated data, I wouldn't have been able to see that, right? So it's very crucial to keep your data raw. Of course, when you analyze and present data, you will need aggregation, but you need to be able to dive in. Monitoring. So monitoring is just everywhere, and you need to use it everywhere, including logs. So just like with the raw data from the previous slide, to be comfortable, I like to collect metrics one level deeper than what I really need. So that way, I know I have more data available if I stumble upon a strange issue, right? Something I need to investigate. So if that level of detail is costly to you, that's something that happens pretty often with SaaS-based monitoring platforms, usually because of licensing costs. Make sure you're able to reproduce your tests, so you can keep extended metrics disabled if you need them to be, and only enable them when needed, when you replay the test that is at fault. 19, dashboard everything. So you need at least two dimensions. You need one dimension for your dashboards within the test, so that you're able to graph data over time, but you also need to be able to graph changes across new versions, right? Across tests. So the reason is you need this to be able to graph trends properly. And talking about trends, so let's say I have this kind of data in my dashboard, right? So it's crucial that the system triggers some kind of alert once we've crossed a certain threshold. Yeah. But let's assume the threshold is way above the current measurements. I think there's room for concern, right? Even if you took the threshold higher, you still need to alert because something isn't right. So you should set up relative thresholds also. So if a test drifts away from the reference by a certain budget, it triggers an alert and it prevents a performance slippage that you would not otherwise be able to capture with absolute value thresholds. And make sure you do it also for low values too, because there's nothing quicker than producing an error. Right, so you need to catch these also. Principle 21. That's a saying, I don't know whose quote it is, but it says, war doesn't determine who's right, only who's left. So you need to document past issues, you need to document root cause analysis steps, and you need to document your fixes more than anything else, because you'll be running again and again in the same problems. And without documentation, your continuous testing practice is at risk. Right. Pipelines. So of course, you should parallelize when you can, because there's a problem in performance testing that's quite obvious. It's the noisy neighbor problem, right? If you run two separate load tests or performance tests on the same system at the same time, and one affects the performance of the platform, probably your second test will be affected. So how can you tell which one of the tests has led to the issue, right? So dedicated environments is a pretty important with performance. The second tip would be to set clear stages, right? To separate the various steps in clear stages, so you can identify where the issues come from. So it's not really related to performance testing. It's more related to test orchestration, admittedly, but still, this level of explainability is quite critical. The third one would be to fail early. Yeah, so and that's something that smoke tests cater to. So otherwise, you lose time and resources doing things that were completely unnecessary because your test is already pretty broken. Yeah. And for the 25th, there's something, if you really want to cater to developer experience, yeah, you provide a self-service mode to rerun your tests with a short feedback loop, ideally on a local environment or a persistent environment that the developer can access and investigate on without being disturbed. And one thing I really like also is soft failures. Yeah, so if your system allows it, and not all orchestration tools allow it, you can use soft failures to signal builds that have technically succeeded but failed to meet performance expectations. So hard failures can be then identified as technical problems that the developers or you will hardly be responsible for. Yeah, so with soft failures and hard failures, you facilitate triaging the issues. 7, and that's the last part of my presentation. Afterwards, we'll go through the questions. If you really take this to heart, your continuous testing practice or journey will have you dive into developer experience on one side and site reliability engineering on the other side. So in terms of shifting left, the shortest feedback loop of all lives on the developers' computers with profiling tools. So your vision should extend to this as well. And about shifting right, organic load is really your friend. So as opposed to synthetic load you generate with the load testing tools, Organic load is your customer's load, right? So it makes testing in production really easy, of course, very simple, because you do not need to automate as much or as many things as you might for other environments. But there are a few hard and very obvious prerequisites. You need to be able to really isolate what you do in this context from what other from what the clients you'd like to protect do. Right? You don't want to affect data too much. You don't want to crash your platform, that kind of thing. But down the road, it's really for the better, right? And it relates to a practice that is called chaos engineering. And if you want to know more about testing in production, you should really dive in. There's a tool called Gremlin that does this. It randomly turns off a few services or creates new issues in your infrastructure. So it's a really interesting practice. And as a last word, a quote, because I needed one, of course. So continuous testing, and especially continuous performance testing, can be, let's say, a test generation trap, where you use most of your time to create and maintain tests, maybe a bit of time, a bit of what's left to analyze results, and none of your time exploring the possibilities. Right? There's a problem, there's a narrative issue in the field at the moment around the fact that supposedly automation is far superior to manual testing, right? But humans do exploratory testing much better. So you need to save time to analyze, because you could probably be running your tests for all your life. If you do not analyze the results, you won't have any value. And if you do this, please keep some time, keep some room for exploratory testing. Yeah. And that's about it. Do you have questions? Does anybody have questions? Feel free to unmute yourself or to type them out, whatever you feel like doing.
I will start. I could ask a lot of questions that the meetup will finish at midnight, but I will try to, because this is super interesting, of course. Okay. Where did you start? Because in the end, from your explanation, it seems like there are a lot of things to learn here. I mean, these are the key things to know. But I mean, if we had to start in doing this, what would be the suggestion? Because of course, we cannot focus in infrastructure, in where to start, how to start, basically.
Okay, so that's a very important question. So thank you for asking it, Aurélien. I think what I want to communicate more than anything tonight is that you don't need much to get started. You don't need big load generation tools. You don't need big infrastructure. In fact, you don't even need load injection tools to get started, because like I said at the beginning, you need to scale for one at first. So what you need is to be able to monitor your platform, and you need to be able to access the application you want to test. Some would even say do not need the application to be running to do this, because there are a series of rules that you can feed into a linter to do static test, a static survey of the code, and it will highlight really bad patterns, right? But still, most of the performance testing happens at runtime. So I'd say stay away from load injection tool as a good point of as a good start. Leverage monitoring and try to understand how your system works. That would be my advice. Yeah. And once you've done this, try and select the most basic business-centric action you can do and automate it. You don't need big loads again. So maybe you can rely on a tool that does, browser level automation and leverage the automation you've already done for your functional tests. So they will give you performance metrics. So there are very specific performance metrics when you talk about a UI level performance testing. I won't dive into that now because I'll take you to midnight as well. But yeah, I'd say this. Start without a load injection tool. And if you absolutely have to, just run the simplest business-centric action you can do. Yeah.
Thank you. There is a question from Lucas.
Yeah.
Which tool do you recommend for your performance testing?
Okay, so if I wanted to be playful, I'd answer none, because most of the time the technologies we leverage have tools in their SDKs that allow us to monitor the system that is running. And most of the time, as testers, we are not responsible for monitoring the platform. So usually the people who handle the infrastructure have already put in place solutions to monitor it. So I'd say you don't need a tool to work on that aspect. Now, if I had to really recommend something, I'd recommend two separate tools. So one, as you could understand, as you could get from what I'm saying, the first tool I would dive into is monitoring. So there's really, really nice tools, for example, Datadog or Dynatrace or New Relic. So there's a series of vendor-based tools that do monitoring really well. Doing monitoring really well with open source is quite challenging because it costs a lot of build time. You need to set up a lot of that stuff yourself, and that's in the end very costly. I've done it several times. I would advise against it if you can. If the licensing fees are not too high, I would go for a vendor-based tool. Yeah. And for the load injection, so I've started on Load Runner when I was much younger. I've also used Neoload quite a lot. So Neoload I love a lot. For the open source or at least free tools at the beginning, K6 is really good. And if you don't need browser level automation, you can look into Gatling as well. Gatling is an excellent tool as well. Yeah. But I would say, so Locust, good question, Aurélien. I'm not familiar with Locust because I haven't used Python a lot in my line of work. So I wouldn't be able to speak about it. But I'd say probably Locust carries a few of the issues that the Python ecosystem carries around performance. So if you do really Python native code, not C++ or C like the libraries, and you need to do really big loads, it's possible that your Python stack is going to be too slow. So I would look into Gatling or K6. These tools are really able to get you to high levels of load injection with not a lot of resources. Yeah, especially K6, since it's based on Go, can do like, I don't know, 10,000 queries per second with 2 CPUs, 2 or 3 CPUs. It's really efficient. Yeah. So another question, yeah, Andreas, K6 is great. Yeah, definitely the hybrid mode is really great, and they have interesting pricing patterns. So if you want to get started, it doesn't cost very much. Any other question? Sorry if my answers are really lengthy. If I need to cut this short, please tell me. Good to know.
Yeah, we had a guy that is working in that company, so he
Cool.
talked about this. I have another question. You talked about the importance of the requirements, and this is specifically relevant for me because it's happening to myself. Is Okay, it's clear. Requirements are very important, but how would you deal if you would work with people that say, "Hey, I need you to ensure that certain feature, certain API or whatever has to work well, but I cannot tell you what means work well. I cannot provide you with KPIs to ensure you will test this."
Okay. So yeah, that's quite frequent to run into someone who says, I want it to work. I want you to make sure it works well, but I'm not able to define well. I'd say you're headed for a disaster. Because if you got in front of you someone who's very friendly and likable and easy to please, your first test is going to pass in their mind because they haven't set boundaries for what's acceptable or not. So it will not reflect the level of expectations of the customers. It will reflect the level of um, the willingness of your counterpart to create a conflict. So it doesn't have to do it doesn't have anything to do with performance, in fact. It has to do with people being willing or not to create a conflict. And on the other hand, when you have someone who is very demanding, nothing will please them if they haven't set objectives, right? Every test is going to be a failed test in their mind. So my advice would be fight back. If they say we want to know if it's acceptable or not, please enter a while loop, an infinite loop. And as long as you haven't heard what acceptable means, do not stop asking why. You just need to ask why. Yeah. It's not acceptable really because their decision will be entirely political, or emotional. It's not based on facts. So that's an issue. So to give you a pointer, what I would do is say, okay, so start from the user. Please tell me if you have data, do we know how frequently users abandon our application based on the performance we see? And if they don't know, ask them what they would be fine with. And I can tell you 100% of the time, people are extremely demanding. There's a figure that Amazon has released years and years ago. And if I remember correctly, the figure was every time the response times increase by 100 milliseconds, they lose 1% of the business. So that's potentially terrible. Yeah.
Thank you.
So I'm reading Andrea's question. So just to circle back on Lucas' question about JMeter. So JMeter is an excellent tool, meaning it has been in the market for a long time and community support is just stellar. There's no other tool that has so much community support, but there's a lot that JMeter doesn't do right. So I'd say, personally, I don't like it. I still have to use it, so I do it reluctantly, but try your hand at this, try other tools and see what you like. That's just what I would say. And Andreas asked a question. Should I read it or do you want to do it, Aurélien?
Yeah, I will read it. How and when do testing on isolated EMS, local servers, Dockers, Kubernetes, versus do it on live environment, so pre-prod or staging, so production versus not production with real infrastructure. In case of developers argue that isolated EM doesn't matter to them till they will see data from real EM testing.
Yeah. That's a good question. So there's a reasonable level of skepticism to have with environments that are extremely flexible, such as local environments, or even cloud-based environments. Some people have this expectation that cloud-based environments guarantee that you always have the same performance. I can tell you that's not true. So it's reasonable to be skeptical. What I would say is there's a lot that can be discovered before we reach bare metal environments. Like I said, most of the performance problem I run into are between 0 and 1, and not really scalability issues per se. So I would say, unless you're talking about a load test, I would say the isolated environments, the fact that you find a defect on an isolated environment doesn't really matter. I would pay attention to a performance issue that is not really related to a load testing one. If it's related to a load testing one, I prefer environments that are a bit more sturdy, a bit more controlled. But I'd say any finding must be investigated. Maybe it's an issue of culture and collaboration, because, well, arguing is good, but refusing to take a hint, refusing to dive into an issue that has been found is not really a great sign. So yeah, there's reason not to do some things, but still I would look into issues that people run into.
Any
other question?
Guys?
I'm sorry, I'm very chatty. I don't want to discourage people from asking new questions.
All right. I would say that we can hand over to Oksana, and thank you very much, Matthieu, for the presentation.
Thanks, everybody.
Yeah, thank you also from my side, Matthieu. So could you please stop your sharing?
Sure.
Then so thank you again for this. This is really interesting talk, and your really good slides. I like it.
Thank you.
So what's next? What's next? So we already planned our next meetup. So it is in less than 1 month, 20th of November. We have our next meetup with Asharani in her topic, AI-powered automation with Copada robotic testing. I hope to see you there. So please save the date, and thank you for joining us today, and hope to see you soon in the next CTM meetup. And the video recording from this meetup you can find on our website, I think within 1 week. So thank you guys. Bye-bye.